First of all, thank you very much to our guests from WIND who accepted to give this lecture. And as most people in the audience know, this is the 7th lecture of the Antonio Picariello series. This series is entitled after the late Professor Antonio Picariello, who helped us to establish the group in data science at the university and unfortunately died last year. And we hope that this series will become a sort of reference point for data scientists in Italy. Today we have a set of, so the first speaker is Dottor o Ingegnere. What's the title? Tagliaverga, you're muted.
Yeah, I'm an engineer. I'm an industrial engineer.
Okay, so Engineer Tagliaverga is the head of data governance, engineering and automation for WINDTRE. And he is specialized in building high-performance pipelines and ingestion protocols. So without further ado, I leave you the microphone and please.
Hi everyone. I'm Francesco. I would like to share some slides. I don't know how to do it.
Yes.
I'm Francesco. Something about me. I graduated in 2009, actually. I'm an industrial engineering, and I always to put things together, fix things, and put all the things, small things in the puzzles together and find solutions. I'm a passionate video gamer also, and probably this is the reason I started my career in data, first as a consultant, and then as a member of first Generali Italia and then WINDTRE. I will talk to you about, since Marcello is not here, I will talk to you about our approach to big data first, and then about data engineering. Then we will have a session with Francesco Fabri, who's the head of data science at WINDTRE, and he will have an introduction for himself. And at the end, we will have Amida and Erika talk about their experience in the company. So I would say we should begin. But first, I will give you an introduction on how we are currently running our practice, and then I will give you some examples and real cases of every day. I would like you to be collaborative and also ask questions during. Just stop me and make your questions. Okay, fine for you? Is it good? Okay.
Yes, thank you.
Okay, so introduction. I don't know how much of the content you already saw in the past. We all know by reading our newspapers that at the very beginning of the big data era, it was like 2013, 2015, this was a buzzword. So the data-driven companies was not structured as it is now. Data-driven companies were just a few. They didn't even know that they were data-oriented companies like Google, Amazon, and so on. Then something came up, and it was the power of data, the power of technologies to transform something that was in our databases into information that was valuable to our businesses. So everybody chose to move not in a very structural way towards the data-driven companies. Some companies did, and WINDTRE was one of the first. And they established this data-driven organization with starting from big data early in between 2017 and 2018, starting with a big bang. So basically establishing a big data company as a big data company and a data-oriented company. So they hired a lot of people, they grew the practice from ground up. What was the idea behind this? The idea behind this was that a data-oriented company was made by three main capabilities that were basically not organizational bodies. It was just capabilities that the company should have to be data-oriented. Okay, so to be a data-oriented company, you needed to have a good practice about data management, a good practice about data intelligence, which is everything about data science and AI and whatever, and also a good way to measure what you're doing. So the idea was to have a cycle that you could ingest data, transform the data, make sense of them, get insights, and measure them. Is that clear for everyone? Does it make sense? The idea behind this is to, I will talk about my organization. So as I was saying, let me try to go back. Okay, I was saying that there is a cycle. You ingest data first, data management, you make sense of them and you gather insights, data intelligence, data science, and machine learning, whatever. And then you try to measure the value of what you got. And then you begin again. And I'll explain to you why it is this way in just a moment. I will talk to you about the organization I lead, which is the data engineering and data governance organization, which is split in 3 pieces. And I will show you then how this impacts the data supply chain, which is this cycle. Okay, so we're split in 3 pieces because we have the same competencies, but we operate in different ways. So we have some people managing processes, committees, and technical sides like metadata, master data. So basically, what you need to ingest and make sense of data, since they come from the transactional systems like CRMs, websites, and so on. And they also try to make sure that everybody speaks the same language. So everybody in the organization, not only the big data organization, needs to speak the same language, and they take care of this. Then we have some other people that are caring about engineering and automation. So basically they take this data, all other data that are already present in the organization, and they try to standardize them and put this data to work. So basically they give data to other organizational structures, including the data scientists. Then I have some people that basically manage the automation of the managerial reporting. So basically what they do is try to visualize this data to measure our initiatives and also basically to give very basic insights to the top management that needs fast information, easy information to understand. Is that clear? So we work for everybody. We work for data science, so within the big data organization and all the rest of the organization, including IT. So we basically serve IT even if we are not a technological organization. So how do we fit with the data supply chain? We fit this way. The data supply chain works as follows. So you basically do initiatives that are the strategic aligned business logic. So you get an initiative, you ingest data, so top part, data management. You then probably build a model, and then you measure the model. If everything goes smooth, so you make a trial, you go to production, or you begin the cycle. When everything is perfect, then you start again, start over. You make another one, you make another model, you make another use case. So my part of the organization basically works within the data management side, borderline the Francesco's team, Francesco's Fabri's team, who'll talk about the data science later, and then the results of what Francesco and other people in the company do. Is that clear for you? I understand it might be a little difficult, but I think it's quite easier once you understand it.
It's quite dense, but we understood.
Okay, do you have any questions so far? If there are no questions, I would go on. So what we did to make this operationalized, so we built basically a hub of competencies within the company. This does not only include our our organization, so the big data organization. It includes basically every side of the company. So we have the IT side that basically develops the systems within the hub. Then there is the data side of the organization, which is the big data group. And then we have all the rest of the company, including IT, the staff organization, and the commercial organization. So everybody works together. We are a hub of competencies, which are scarce resources. So everybody asks something about their problems. We try to solve them, and we try to solve them with the technology guys. So basically what we do is solve problems. Everybody comes with a problem, then we need to translate it into an analytical problem, data that we need to gather, data that we need to standardize, and results that we need to give. The last part of the action is to operationalize it and basically do some campaigns or whatever is the solution of the problem. So we'll talk to you. So as far as we understood, we have three big areas in our big data company. We have one part is governing, managing, and enriching the data, applying analytical skills and machine learning to extract insights, and then measure the business results. I will talk to you about the first and the last one, because this is part of the organization I lead. I will talk to you about the objectives we have, and we'll give you some real cases. First things first, we have 6 main objectives in the company, in our organization. First of all, is that we need to establish a common organizational model, which is actually an operating model where everybody in the company is involved. So since just for the rule of case, there are hidden patterns within everything, so even in the organization. So what we do basically is that we establish a framework where people within the company talk about data related problems, and we try to solve them. So we build a super organizational item, which is a council, with every part of the organization, where every part of the organization tries to solve their own data related problem. Another objective, big objective, is to share consensus. So basically that everybody understands each other. Just think about people. I'll give you a real case example. You are students from maybe engineering, economics, and philosophy, probably, you know. You need to try and find a common ground to solve your problems. To solve your problems, you need to speak the same language, and also you need to share the same objective. So this is what we do. We try to find a semantic layer that basically everybody understands. The other side of the problem is to give the right definitions, because it's always a matter of language. What we try to do is to establish the metadata layer that basically is the other side of data, and tries to fix the problem of what do you mean with from a technical standpoint, what do you mean with this data? We try to enrich our data layer with the external ecosystem, since the world is going to that direction of companies merging their services to each other. So basically we have the problem to understand who's the owner of what data. As you might know, you probably experienced it already, you can try and find collective data in open data, for example. That's another topic that we need to issue. And another objective we have to understand and to address is that we work with other data-oriented companies. Our providers and our clients are also data-oriented companies, and what we need to do is to basically become the center of an environment where we share data, we share insights, we share services. We live also in a world where data privacy is a big issue. you might know from the news, we need to make sure that everything we do is compliant, but also we are addressable for the treatment of data that our partners use, basically, and that we provide. So, in short, I will give you a brief explanation of the work we did so far, like 2 years from now, and 2 years and a half from now, actually, and the work that our team did to establish this data governance and the engineering framework within the company. So basically what we did is establishing a very big council of 80 people across the managers of the companies, where we standardized the data model. We standardized the data owners for each data area. And we defined the processes that we are implementing. We are actually quite late on that, but we are undergoing a huge development on that. We standardized a lot of the information framework that we have in the company, and basically standardized 80 metrics that everybody can understand and talk about. So in short, what we did is trying to make a huge standardization project within the company in the last 2.5 years. And I understand you have a lot of questions. You might have a lot of questions because I didn't tell you anything about what we actually did to make this. And I'll give you just 2 real case examples, and I'll leave you to your questions. If you don't have any questions right now.
Well, actually, I have one. Could you please give us some more details on this standardization process? What do you exactly do?
Okay, so to standardize, I'll try to rephrase it. Let me know if I understood correctly. You're saying I would like to understand more about how you manage to standardize the language and the data model within the company. Okay, just to let you know, WINDTRE is a merger of more companies in the last 10 years, 15 years, like many other companies, like major banks, insurance companies, and also telcos are basically coming from merger and acquisitions. If you remember, Infostrada is the landline provider for the first private landline provider is part of WINDTRE. Now it doesn't exist. It's basically our fixed offering. TRE and WIN were 2 brands that are now absent. We don't have them yet because we have only WINDTRE. Everything is WINDTRE right now. So basically we merged a lot of companies together. We merged our systems. So the issues that we had is that not everybody was talking the same language in the sense that, let's say, revenues is a common word. Everybody uses it. But let's say WIND and TRE had a different way of treating these 2 metrics. So what we did was first create what we call the data governance committee. So basically it was sharing the consensus, as I was talking yesterday, a couple slides ago, sharing the consensus and basically building a committee of middle managers, top managers, where we discuss what revenue means or what metrics means. What we did is that we put together the commercial side, finance side, and IT side to discuss what exactly that metric means for WINDTRE, not for TRE, not for WIND, not for Infostrada. It was for the company, for the investor. Okay, so we said we need to find a common ground. We together define what we need to measure, and then we build it. So,
but if you, I mean, according to what I say, therefore, basically, you adopted the standard definition for which works for the present and the future. But how do you deal with the past? Because I mean, merging companies, you also merge archives and you merge records and so on. So do you have a sort of a tree or semantic tree which leads Okay.
Yeah, we build a semantic layer. So what basically we did is that we have different stacks. Okay, so we have the stack, the Wind stack, and other stacks. Okay, so stacks mean the applications. So Wind CRM, Tre CRM, and so on. So what we did is building the common data layer, which has same definition for all the companies that were previously part of the company. This is standard actually. Every company does that. Every company does that in a merger. Every company does that when they change their systems. So they build something that puts together everything. But this is not a one-off effort. It's not a technological effort. It has to be top-down. It has to be from the top management down. So it's basically very difficult to put everybody on the same ground, since they also talk different languages. So finance people maybe do not even understand what number portability is, but they need to talk our language. We need to build consensus, as I was saying. We need to speak the same things. They need to be aware of what we of what commercial measures of, and commercial needs to understand what finance measures.
Thank you very much.
This is the big, what you said is the biggest challenge that we have right now.
Well, I mean, if I can spend a few words on this is basically the main idea which we laid behind the project of the new Master in Data Science, which is organizing these lectures. Because basically we have clearly in mind the fact that you need for a data scientist to be very good on the methodological side, but also to be a domain expert, because the problem of interacting with the domain expert is almost the most difficult part of the job. So basically you need to build a common language. And, I absolutely agree with what you are saying. So
I agree. It's the most difficult challenge. Yeah. It's the most difficult challenge for people who are experienced as well. It's not, even if you have a lot of experience in the field, this is the most critical challenge because it's a cultural challenge. It's not a data challenge. This is most valid if two companies merge and they are quite different. One example, if you, I think the meeting is ending. The meeting has been upgraded. Oh, okay. This is the big challenge because there are conglomerates in the world. WINDTRE does not only sell telco services, it sells other services like technological services. The most difficult thing to understand, to make people understand, was that when you talk about services, you're not talking about selling a telco service. And this is an everyday job. And to make sure that you overcome this problem, you need to make sure that the top management agrees that you need to find the common language. You need to push so that everybody speaks the same language. And also, once you establish the metrics you need to follow, you need to reach, everybody rows in the same direction. It's two challenges: speak the same language and row in the same direction.
Thank you. Any other question?
So in short, how we did it, just to end up, we created a big organization, sub-organization, where middle managers and some top managers live. Like weekly, they meet weekly to solve data-related issues. So they share, so they familiarize with each other, they talk with each other. Any other questions? Guys, you're young. You should make a lot of questions.
They're young, but they are also exhausted by this period of teaching online, I think. I mean, you know,
yeah,
this is really,
yeah, it's the same thing for us. I'm actually in Catania right now. I'm not in Milan. So So at my house. Yeah.
Well, yeah, I know, but that's a bad part of this period. Let's forget about it. So, Flora,
Yeah.
are you around? If so,
Okay.
yeah.
Okay, so I will give you two real case examples of what we did, just to give you some hints on what we did. And what we did on two challenges, big challenges we have and Amida later will talk to you about some things that we're doing more in detail. I will give you two examples of what we did, what we're doing with data actually, and what we are trying to, and how we are trying to change our company in the way it works. And it's first challenge. Technical, it's a challenge from the technical standpoint and on the people standpoint. What we had was a lot of people doing managerial reporting by hand, meaning they extracted data by hand, they put together data by hand, making a lot of offline systems that they had in their servers or PCs and so on. What we did, the challenge was not a big architectural challenge, actually it was more of a, we need to do a lot of things with a single architecture, was to collect all the needs from the top management and saying, okay, which are your top priority reports that we need to issue, even if people are not in the office. So basically, what reports do you want us to send you by machine? So basically, substitute men with machines on Sundays, Saturdays, and holidays, basically. And what we did is basically build, we have a Google platform that we use usually to, not only the Google platform, but we have Google platform to use as a big data platform. And we are using this Google platform to deliver basically this report. So in the beginning, we had like something like 20 people doing reports by hand. And now we have much less people. So basically what we did is, trying, as you follow the slide from the left to the right, we tried to collect everything that was offline in a storage. Then we substitute, so we changed the business logic that everybody was doing by hand, we did with a machine, orchestrated with Google Cloud Composer, that is basically an orchestrator. So we basically replicated the man-made logic with Google Cloud BigQuery as table and table storage, and Google Cloud Composer to orchestrate all the operations. Then we save the results, aggregated results to be sent to the users in the storage, so Google Cloud Storage, and we used Kubernetes engine basically to offload and parallelize the load, because a lot of those calculations were quite big, I would say, to be done by a machine. And then we are basically using the orchestrator, sending these contents to the users via email, and also via pushing this data to MicroStrategy to interactive dashboard. So in this example, you see the work of the data engineers, the pure data engineers on the left side, basically, top left side and bottom left side, and then on the right side you see the work of the reporting and automation, the visualization guys, to standardize the reports that go basically to the commercial department, to the head of the commercial department, is the boss of our boss, and or the first line. In this case, what we did is basically replacing people with machine. This doesn't mean that those people are now they don't have a job. They actually have a more exciting job right now. Their job is now to analyze those data. They used to make their day by making the report, which is basically nonsense. Now a machine gives them the report before 9 a.m. every day, including Saturday and Sunday. And during the weekday, they can analyze the data. So they do a better job, a more higher quality job. First challenge completed. We are actually working on this. We are making more and more reports like this. Questions? Technical questions? Why didn't you use something else? No. Why are you using Office? No. Nobody? Okay, so last 2 minutes I will spend it. It seems, this case seems quite simple, and it's not. It's really not, because the challenge here is not to replicate one report, is to orchestrate all the reports that we have to make, which is like 20 reports before 9 AM when they are available at 8. So basically the challenge is here to produce all the reports between 8 and 9 AM, basically, before people start to work. Okay, and this allows us to change the process of reporting, standard reporting. I will show you another example, which is far more difficult, but it's only one business process that we changed, which is basically a business process that we changed this way. So we had some people, yeah. The first challenge was to find one architecture for all the reports. The challenge here is to avoid people working for like 10 days. A machine can make it in 2 hours. Okay, so what our job, I will not talk about data science right now, because we work also for Francesco's team, and Francesco will tell you about data science. What I want to show you is that big data can be data science and much more. And big data can change the way a company works, because both the technological side and the people, the young people that know how these things work, can make a company a different world. Okay, so at first we had, in this case, we had a business process where some people were making a lot of extraction and manipulation with a higher level of error on basically a pipeline managing like something like 100 million euros, something like that. A mistake in 1% is million euros, okay? If a human error here costs a lot. So what we did is change the process. So as a big data team, what we said, okay, change the way you work, because there are other ways to work. We can make our machine work for us and use the people that made this manual adjustments, manual iteration close to the business side. So we are shifting the way people work here. So we're not only making automation, we are not making human people less usable, less of use or unusable. We are making them, we are shifting them to a better work. So these people used to aggregate data, which is quite boring, I would say. What we did is changing everything, change the process, put some machines to work, and everything is done in 2 hours. So we mapped the full process, we changed the process, we made ingestion layers, and then everything works. We estimated that we saved something like 10 to 12 FTEs a month. So the full-time equivalent people that can now work on different topics.
Quite impressive.
But this is the power of people and the technology, right? Big data technology. Yeah. Questions? No question. Yeah.
I believe the last slide was so compact that it was almost impossible to read, unfortunately.
Unfortunately, it's not possible to read, and this was done on purpose because there is some business process written within. But I wanted to give you the idea of how complicated it is sometimes to make something very effective and change the way the people work. So I would like to give you the feeling that we are doing something that's really, I talked about like 10 slides about the hyper-Uranian, everything that was top level. But now I'll show you that what we are meaning, we do it. We do it by hands, with our hands, with Amida, Erika, and other people's hands, my hands, Francesco's hands.
Can I ask you something?
Yeah.
Yeah. So what would you say was the hardest thing in this project for you? The complexity of the data, or the need to have a solution that was fast enough to deliver in a very fast timepiece?
Okay, the real challenge, you're asking what's the real challenge, correct?
Yes, indeed.
Okay, the real challenge here is that we had, a thing that I didn't tell you, is that this process was cross-commercial unit. So everything you can imagine between big data, marketing, CVM, reporting, everybody was on board. This process was cross the full unit. So basically, full commercial unit is like a couple thousand people. This process was fully crossing the unit. So the real, this was about, I can tell you, it was about B2B business. So a small part of the unit, but still quite big. And people within the project had really different objectives. Everybody had their own objective. And the real challenge here was to optimize everything, I would say. So make it fast for the people who needed to start the process at the beginning of the month instead of at the 12th or 15th of the month. Okay, this was a challenge because you needed to find a solution that worked for everybody, basically. So everybody had to give the data on time. We needed to extract and aggregate it on time. We needed to find the right time to compute those data. We needed to find the right technological component to aggregate data and process data. This was the big challenge. The big challenge was putting everybody on the same table and find a solution that was fit for everybody. It was not the coding. It was not the data. It is hugely data intensive, usually. But with the technology we have right now in 2020, everything can be done.
I understand. Thank you.
A lot of time was spent on that understanding, for sure. Yes, because we don't know. We are not specialized in any business process. We are not B2B people. We are not B2C people. Okay, we are big data people. We don't know every specific process. So a lot of effort was on the understanding. It's true, but the real challenge was to make this process fast for everybody. So a big upper side for everybody, a big upside for everybody. Did I answer the question?
Yes, yes, of course.
Okay.
Thank you.
It was much more
So part
difficult.
is to deliver everything at schedule with different groups that have different problems at the right time and understanding the needs of everybody. So
Yeah, correct.
This for you,
so, yeah.
for you guys was maybe the hardest thing. And then you had to find the right technological solutions, but the solutions are there, you're saying.
Yeah, yeah. The technology parts are there. The ecosystem is so wide right now that you have everything basically available. It was more challenging for us since we had so little time to do the job, this one. This is more challenging because you need to do everything between 8 and 9 a.m. And you have to deliver all the reports between 8 and 9 a.m. So you need one architecture that fits everything.
Yeah.
This is more complicated because you have different problems with one architecture. Here you have one architecture for one problem. Here the complexity is to orchestrate everything. Any other question?
Excuse me, which platform do you use for resolve this problem? Like,
Okay.
TIBCO or SAP or...
Okay, so we use Google Cloud usually. So the main part of our architecture is based on Google Cloud services. So just to give you some examples, if you need to have servers or computing engines, you use the compute engine service. If you need pure storage, you use Google Storage. Everything is basically interactable with APIs. So if you need tables, databases, you can use Bigtable or BigQuery, depending on you need distributed computing or not. So you have options. We use for the front-end layer to report data, either Data Studio within Google or MicroStrategy or Tableau, which are outside Google. We use Dataflow for ATLs, or we use compute engines and Python, for example. We use a lot of architectural components, really, a lot. Everything that we can use, we use it. The main backbone is Google Cloud, for sure. But I can tell you that you can use Azure or Amazon as well. Services. It's technologically independent. Every system has its own upsides and downsides. We use Google because it's our platform right now. So
Okay,
for example, you can do it with a machine, or you can use Airflow.
Okay, thank you.
You need to study a lot. You need to study deeply the platform to understand which component you need to use. And also there are interchangeable services. So for example, if you need fixed storage, you probably want to go towards SQL service in Google. If you want Cassandra service, Cassandra-like service, you use BigQuery.
Yeah.
So basically, you have a set of tools that you can choose, and we are quite lucky because we can use basically everything with Google, which is our partner. It's pay-per-use, so we need to make sure that we don't use too many resources, and we need to right size as well. We cannot use many resources because it costs depending on the cost depends on the resources you use. So we need also to right size. Let's say I want, like in a compute engine, I want 12 cores and 200 gigabytes of RAM. We cannot say 2 terabytes of RAM because it would cost a lot.
Other questions? Okay, I leave Flora to introduce the next speaker.
Yes. Yes.
Thank you very much.
Thank you.
Thank you. Thank you very much. Thank you. And no questions? Okay. Okay. It's my honor to introduce the next speaker, Dr. Francesco Fabbri.
Hi, everyone, and thank you all to be here. It is a great pleasure for us to be here and share with expertise with you. I also have prepared a couple of slides to support our discussion, so I'm sharing my screen. Just a moment. Okay, hope you can see right now.
Yes.
Perfect.
Yeah.
Okay, great. Just a quick highlight about me, about my journey. I got my master degree in computer engineering. After that, I spent some years in the consulting industry, supporting industry, setting up journey and capabilities related to data and analytics. I joined WINDTRE in 2018 with the objective to lead the data science and AI practice, and at the end of the day with the objective to support our business decision and personalize the customer journey with data science and artificial intelligence methodologies. I choose to, I hope all of you are in the technical background. I understand most of you are from data science academic path. So I decided to size this interview discussing with you and brainstorming about which are in our, from our point of view, the trending forces in the data science ecosystem, and how, which are the maturity of the company and in WINDTRE in particular on these forces. So I start from the early beginning, and as most of you well known, we are live in a world made of data. So from 2015 to now, we have augmented 5 times the volume of data produced. And for the 2025, the estimate is exponential, and for sure in the year that are coming, we see there are more and more data. We live in an industry and in a company which is fortunately data intensive, since as WINDTRE we have the larger market share in the Italian market. We are talking of a customer base of about 28 million customers, as well as 20,000 more or less transmission sites for our top quality network, because we have now in Italy the fastest transmission mobile network available. We are very proud of that. And to handle this incredible, enormous volume of data, we saw that also technology is rapidly evolving. I suppose most of you well known as this kind of curve, which is the Moore law, and which has governed the market till at least one decade ago. But from some year reached a kind of plateau, so which is in part compensated from different type of processing unit. Imagine all the power handled by GPU and for specific problems, because at the end of the day, GPUs are running computations on matrices, and as well as quantum computers, which are so far to achieve and outperform the traditional hardware in as generical purpose computing. But for sure there are right now, even if we are in an early stage, a subset of a specific application where they outperform in terms also of order of magnitude, the existing algorithms and solutions. So which are the challenges for the data science in this exponential growing world? For sure, you need and you have to leverage on the computational power to find pattern and relational in this growing volume and heterogeneous data sets, to find to solve optimization problem in a combinatorial space. And we live for sure in an industry and academic world which is constantly evolving. So you need to keep pace regard the latest innovation and the latest algorithm and research. A quick word on the role of data scientist on this process. You can find here an article is almost dated because we are talking of 2012, and we are at the beginning of a phase where companies for the first time realize that they can achieve a better result and realize value through the use and the application of data science approaches to their corporate data. But in the early stages, but even now, there is a lot of confusion in what a data scientist is and which are the capabilities needed to be a data scientist. There are a lot of funny charts which intersect almost any discipline, and it's quite confusing, and it's quite hard also to gain on the market to select and identify which are the people that the company needs. We have a very strong point of view on that. We don't need that exist people with all the skill and capability, but we need and we need a team that mix a skill of a different discipline, where you have different kind of profiles which have an horizontal knowledge on all this topic, but a vertical detail and awareness of a specific topic. For example, talking of natural language processing is nowadays a discipline which is very, very broad and which encompasses a lot of specific techniques among general machine learning. And the team that succeeds on that is the ones that are able to share this expertise and collaborate to solve business issues from different perspectives. We are also living in technology landscape and ecosystem which is very wide and constantly evolving. 10 years ago, the tools and the techniques available are mainly provided by specific technology suppliers. And now I think that the open source ecosystem have surpassed every specific and proprietary tool, and even all the academic research have direct and fast implementation in open sources tool. So it's quite important also from a data scientist in the corporate environment to always take a look both at the academy as well as the open source research to find, based on the use case and the problem, the business problem you need to address, understand which is the specific tool, as Francesco also anticipated in their previous discussion. So just to recap the very basic from maybe your first statistic course, we saw that the computational power is growing, and we are able to tackle and wrangle even more complex and high volume data set. But at the end of the day, machines are very good at finding correlation. So we see here a couple of curves which provide the seasonality curves for ice cream selling and people that go swim. The curves are very correlated, but based on this scenario, maybe you want to understand from a business point of view if the ice cream influence swimming, or on the other hand, if swimming influences the sales of ice creams. Or maybe if you have also got a good mark at the exam of statistics, you can find a latent variable which influence both of them. So the key point here, over these basic samples, there are a lot of strange correlation which does not imply at all causality and causal nexus. We talk about that, of spurious correlation. But in general, the key message behind that is that business want to identify and understand causality between events and effects. So it's often important to pair the algorithm and the output of the machine with a human in the loop approach. So having the human that provide the distinction between correlation and causation, even if also from a research perspective we are growing also in the algorithmic approaches which find causal nexus. So it's even more important to have and focus your data science and machine learning approaches in an explainable way. So even more, the black boxes for sure have achieved a very good level of performance in terms, for example, of accuracy. But we need also to pair them with mechanisms that are able to break the box and understand which are the key rule and the key variable that the model chooses to perform its decision. And for sure, also on that, there was a great focus on the academy research and the industry research. And now we are able to develop models which are explainable from definition, and usually are the less accurate in accuracy. For example, here you can see a tree-based classification problem. You can understand which are the choices that the algorithm made, and understand which are the key variables that affect and influence the decision of the algorithm, both at local level or at global level, if you have if you take in account of the what we call feature importance, and understand which are in the way where we move, for example, from decision trees to random forest or boosting algorithm, which are the variable which are more important to for example, distinguish between the target classes. But fortunately, most of the research in the last few years also allow to enable local and global interpretability of black boxes model. I hope that most of you have heard and know the SHAP methodology, which in effective train a simpler model near in parallel with the black box and try to provide scoring on the different variable and feature used by the model to let the analyst, the data scientist understand in the local cases which are the variable and factors that push a prediction in a sense or in another. So for example, here we see the SHAP methodology applied to a well-known machine learning data set, which is the Titanic one. And this particular article want to explain why Jack have a greater probability to not survive compared with Rose, and based on the element and feature that the algorithm used to make and influence the decision. I think also from a business perspective, it is a changing pace because even more we need trust in this kind of model, which affect almost any business decision. And in applying this methodology really facilitate the interaction between the data scientist and the non-technical colleague in the company to understand which are the important features, for example, to a specific business phenomena, as well as to put the basics to understand the causation and also to better find action to address this issue. For example, part of our work is to understand which are the customers which are more likely, for example, to leave our company. So the matter here is not to provide a model, a black box, which is very accurate to find the people who leave, but understand the causes and then put in place initiative and action from a marketing perspective to touch and solve these causes. I think another great trending forces is all what implies the automation of machine learning workflows from recent statistics, but I think as more as we evolve in methodology is quite unchanged. And what came up is that the greater part of the effort of data scientists are in cleaning, processing, and collecting data, while what we want is to focus on the modeling side as well as to understand which are the output of the model and find solution based on the outputs. So the objective here is to adopt and design a set of techniques to automate all the manual activity of the data scientist. So from the data collection to all the feature preparation, as well as the model generation, because what you want at the end of the day is not to test one single model. For example, for a classification problem, you you can also apply 10, maybe more different type of algorithm. So the objective here is to leave to the machine and the computing power to test all the possible approaches to solve a problem and understand the one which maximized a kind of metrics that the data scientists specify, which is based at the end on a business case metric. This both from the model selection side as well as all the hyperparameter tuning.
Can I ask you a question before you proceed, sir? How many features are we talking about? I mean,
how many features are we talking about? We spend a lot of effort to rationalize what we call a feature stores, which are all the information elements we have for the basic entities we use in our predictive model. So for example, for sure, you have the key entities, which is the customer. And based on that, we systematically synthesized an order of 5,000, 6,000 features for each customer. And then, based on the problem, we built an automation framework which imply a first stage of feature selection to identify among the 5,000 variables which are the one that are more likely to solve the problem. I don't know if I answered.
I would like to have much more time to discuss with you about this topic. Thank you very much.
Maybe we can handle it offline. It can be great. So we spend a lot of effort in automating all these kind of activities because we need to have our effort focused on the modeling side. So we also reduced a lot the time to market to produce a new kind of algorithm or model. Thanks to this approach. We are talking about days in respect to months in when we haven't automation framework. And also that the open source community is growing a lot, and there are nowadays a lot of tools which are easily to integrate to automate both the scheduling of tasks and the monitoring of tasks, as well as tracking of experiments. Tracking of experiments, because for sure, since we have very limited capacity, we want to be sure that once we defined a business problem which can be supported by a model, we also want that once we well define the problem, for example, once we want to understand the customer who will churn in the next month, for example, we want a model that is able to both serve a prediction as well as retrain itself periodically in time. This because for sure we are living in a dynamic world and market, and maybe the features which are relevant to the problem today are not the one of tomorrow, as well as the feature that we use to train the problem can suffer some data shifts over time, because we are, for example, pushing customer in different offers, or because the pattern of customers changes over time. So it's quite important here to have automated control and the platform that are able to implement what we call the continuous learning. So you define the problem, and then the machine and the automation framework is in charge to periodically analyze the feature, analyze the performance of the output, and provide alerting to business user if something in the dynamic of the market changes. Another very interesting world from the academic perspective we are trying to implement in our business is the one related to reinforcement learning. I suppose that most of you are familiar with these approaches. We start from a very simple principle in which we have an agent which live in an environment, and upon of an action from the agent, the environment provide back both a reward and a new state. This is for sure a lot of gained a lot of effort and evolutions, also supported by neural network, and in particular on that we are talking of deep reinforcement learning, where the intelligence of the agent is expressed in the term of neural network. You can see in this funny video on the right an agent, a deep reinforcement learning agent, which learn to play Super Mario by, at the end of the day, dying a lot of times. And so here, based on this feedback loop, the agent can retrain and adapt the layers and the weights within the neural networks to finally solve the issue. And based on that, is not only limited to Super Mario, but in most of the games, machine have overperformed humans. And the problem here is also to understand, to apply this kind of algorithm techniques to business issue. At the end of the day, for example, to tune the effectiveness and the performance of the customer journeys, for example. Just as a last topic and the point of brainstorming with you, there is another, I think, very even more clear and fundamental topic on all the machine learning research and implementation in the company environment, which is ethics and fairness. Just to provide you quick examples, we even more leverage on algorithms that provide solution and make decision in terms to substitute humans in some cases, we can say. And here, for example, we have Amazon that have trained a model which automates the screening of CVs, but they found that the algorithm they used was biased because they trained on the historical subset, and they have more applicant men than women. So in this case, the algorithm was biased to suggest more men than more women. So we need to pay a lot of attention that in all the model we train. And the difficult side here is not only where you have that the bias comes from a feature that you use in the model to provide the prediction, but another example from Optium, which is a key stakeholder in the management of the healthcare in the US. And they found a biased artificial intelligence algorithm in the prediction of patients which need extra medical care. And here the bias was on race. Even despite they were keep race off from the feature that they use to train the model, but the subtle difference here is that race was highly correlated with another feature they use for the model, which was the care history. I think that most of you saw the photo of Obama from this startup, which have the objective to take a pixeled picture and gain back as the high resolution picture. And well, no word about that. This is for sure a topic we all need to be aware, even when you train and put decision behind our model and the data we would like to train the model. I leave you with a couple of quotes from a team which is trying to push this aspect also from a normative perspective at the European level. And one statement is not unlike our parents and mentors try to instill concept of fairness and equality in children and students. Coder could endeavor to make machine reflect the better angles of our human nature. And the good news on that is that the biasing humor is at the end of the day harder than the biasing machines, because on machines we are able and we need to intervene. So let's use the space from I would say no more than 5 minutes because we are running quite late for questions.
Can I start while other people collect the idea? First of all, thank you very much. It was very interesting. And let's say that, as you can see from my background, I come from a different field of application of data science, big data and data science. I have 2 comments. First of all, I absolutely agree with you on the emphasis put on ethics. Ethics is much more important than law. And this is why in our master, we substitute the compulsory exam on legal aspect of big data with an exam on, it's the only course in Italy of ethics of big data, which I think it will be a crucial issue in the future. It's something where we really should need a much wider discussion, because that is really a problem. And for the student present, I recommend them to read the book Weapons of Math Destruction by Katie O'Neill, which is a fantastic example of how dangerous can be the bad use of big data. Then I have a question for you. I mean, you spoke about biases, but I would like to know more how crucial are in your field and errors in the data, because this is something which is usually ignored in most industrial application or also economic application of data science. And machine learning based tools are quite bad at dealing with errors, measurement errors, ambiguities in the knowledge base on which you train your tools and so on. Do you have any do you put any special care on these, or is it something which is not crucial for your company?
Well, yeah, errors. I think is a quite wide topic. We have a lot of issues in that field, and we spend a lot of effort in general on the one side to monitor the distribution and eventual exceptions in the data sets we use and we industrialized, even in the continuous learning scenarios that I told before. What could happen is that, for example, on one day, an information is missing because the system those specific day was down, as well as you one day found another value in the domain that is not compatible with the feature you and the distribution you train the model. So on that we take a kind of proactive approach to monitor systematically all the data we use, both for the training and the continuous training and the serving of variable, using alerting system to identify and detect this potential situation.
But you do it in the pre-processing, basically. You don't do it inside the models.
In the pre-processing, yeah.
Okay,
exactly.
So that's because that is something which is crucial for us. You know,
yeah,
we are implementing methods to do it within the deep learning algorithms and this type of things. So it's I just wanted to know.
I think there are a lot of space of improvement on that, because having these logics applied directly on the model or on the model output could for sure avoid potential situation where the model failed to give prediction, in which in our terms a failed prediction is a damage in terms of value and business. So I think is critical, and this for sure will be another trending topic, and I expect that most of the research will go in this direction. So great to understand that also you and on your side and your research are tackling it.
Thank you very much.
Thank you.
Thank you.
Okay, if there are no other questions, I will let the floor to Amida.
Yeah. Okay. Now I'm introducing the next lecturer.
Thank you all.
Thank you.
Thank you. And the next lecturer is Amida Kudasheva. Dr. Amida Kudasheva.
Exactly. Okay, hello everyone. I'm Amida Kudasheva, a data engineer in the Department of Big Data at WINDTRE. So I'd like to share my educational and work experience so the students can have a vision on how they can apply their knowledges in our field. So first of all, I received my bachelor degree in applied informatics in Russia, because I'm Russian. After that, I decided that I need some experience abroad. So I looked for a European university, and I chose University of Pisa, where I enrolled in a master's program in data science and business informatics. Here, I want to point that my educational background is focused on both technology, technical subjects, and also economics. So I had subjects like programming or databases, and at the same time, economics. And during my last year of study at the University of Pisa, I found out that there would be a recruiting day at WINDTRE. And as the result of that recruiting day, I was selected among other 20-25 students to be part of the internship program, which is called On Stage. So the internship was for 6 months. I worked in the same team where I work now as a data engineer. And after that, in the end of an internship, I was hired as a data engineer. Also, I done my thesis at WINDTRE, but my thesis was in data science field. So I had an opportunity to work also with data scientists of our company, which is very important and very interesting because like I worked in data governance as a data engineer, but also I had an opportunity to work with data scientists. So as a data engineer now, I work on different types of activities. For example, development of custom data pipelines that extract data from different sources, elaborate or validate data, and load it to our data platform, which is BigQuery of Google Cloud Platform. Or engineering and automation of company processes, which was described before by Francesco Tagliaverga, the manager of our department. Or feature engineering. Another activity can be development of applications that perform data communication between different units of the company. Or also automation of institutional reporting dashboards, which was also described by Francesco. So I tried to talk very, very briefly because we don't have much time, I guess. This was my experience. And I have to say that almost all of the subjects that I studied during my master's degree and during my bachelor's program, I applied them while I was working because, of course, a theory of databases, we need it because we work every day with BigQuery, or programming because we write all these pipelines in Python, so we need to know how to do it right. Or even business process modeling. It also is another important subject that can help me to work with the activities that we've done. That's it. If you have any questions.
This is the right time to ask, sorry, Francesco again. This is the right time to ask Amida what the data engineer does in a company. So if you have any questions, for example, Amida loves K-pop, and we discussed this a lot during our joke. So if you have any questions to Amida, this is the right time to do. So if you want to be data engineer, either working on business process improvement or data science field, this is the right time to ask her. So what's it like to be a data engineer, or what do you do daily? This is the right time, okay?
I don't know, about tools that we use. This argument was also talked by Francesco, like we use Google Cloud Platform, and almost all the services that we need and that we use are from Google Cloud Platform, like even storage, BigQuery, Cloud Functions, Cloud Build. There are different services that can help us to create efficient processes and efficient pipelines and applications.
Do you consider yourself more a data scientist or a domain expert?
Yes, I consider myself a data engineer because I had an experience, like for almost more than a year, I work as a data engineer. So I have more experience and I consider myself as a data engineer. But of course, also the part of data science is very interesting, but I didn't have an opportunity to work deeply in this. Like my thesis was in data science, but it wasn't very deep into data science. Like I didn't develop any new model or something. That's why I'm more data engineer.
Almost no one developed new models. I mean,
no, not new. Yeah, I know. But I studied like the model that they already used. So I made experiments on something that was already there in the company.
Questions from the students?
I have one question. So usually how long do you work on a single project, or do you work on more than one project together? What's your usual workflow in your company?
It depends on the activities that we have to submit, but usually we work on various projects at the same time. And then it also depends from other units with whom we have to perform this activity, because we have to communicate with data scientists or with other business units, and depends also from that. Like, I don't know. For example, the one...
It ranges between 15 days to several months. It depends on the complexity. Yeah, Amida is right. It depends on what you have to do. So the business process, first, it took like 3 months. Making one report within the architecture that we established takes roughly 2 to 3 weeks. So it really depends on how complicated it is.
Yeah,
I would say. Amida, do you have any? You have more hands-on, for example, on that big project that we're making on the offering side. So it was long. It started like 1 year ago. So you know the offering mapping.
Yes, yeah. It was a big project, and we spent like a few months to perform it, to create this application.
Yeah, and it's still ongoing.
Yes, it's ongoing because requirements change, and we have to adapt the application, and we're always in communication with the business department, so it's still ongoing. Or another process that Francesco showed to you before, that was a big pipeline. That one was done in a month or more. I don't remember well, but it was a complex one. But we worked together, like not only me, but a few data engineers work together on it. Other questions? I don't know if we have enough time, or maybe it's better to let Erika talk already.
Yes, of course.
Mm-hmm.
Okay, thank you, Amida. Hi, everyone. I'm Erika, and I am a data scientist in WINDTRE. My background is analytical. I have a master's degree in statistics, and I'm actually also an MBA candidate, so I'm also having a business background that is helping me a lot, because I can focus better on the business needs during our data products. Before joining WINDTRE, I've been a data science consultant, and also I've developed some solutions as an R&D researcher from my previous company, focusing on natural language processes. And I've also co-founded during my studies the first Italian Data for Good association. That was a very nice project, but it required a lot of time. So after my studies, it was difficult to carry on that project. And I joined WINDTRE in 2018. Was one of the first data scientists in the team. And joining WINDTRE for me was a very happy choice. Before in consultancy, for me was very difficult to see a project end to end. So this was due to some capacity limits with the staffing. And now in WINDTRE, it's I can see a project from the beginning to an end, and to an end I mean see a model in production. And actually means also receiving a notification on your smartphone and knowing that this notification is also impacting millions of users. And this is very exciting, and it's nice because it's your work. So this opportunity means a lot for me. And also one of the other reasons that took me to give up with consultancy was that I was working with a lot of big corporations that, okay, let's say an euphemism, but not very open to innovation. So the top management was still focused on proprietary software, very close to innovation in the sense also afraid of open source softwares with a lot of legacy systems and a lot of drag and drop programs that were very difficult to use, and it was impossible to customize our activity. And so in WINDTRE, I found a company that had invested a lot, as Francesco Tagliaverga mentioned before, on the cloud infrastructure. And for us, it's very important to have a technology like that. Technology is an enabler, but it's very important having a technology like that in order to deliver data products with the latest technologies. So, okay, this was speaking about technology, but also people, because my team now is we are quite big, let's say 20, almost 20. And we are very, very young and passionate with a lot of different expertise. And there are also, as Amida mentioned before, also interns. And this for us means a lot because they are fresh with their studies and give us a lot of contribution with new ideas and new. They're very passionate and it's a very good balance to have very expert personnel and also new fresh students. So a very nice environment. And also people very pragmatic, concrete, and that have studied a lot, but also very focused on the final products. And for me, it's very important to be surrounded with people that are able to have the right questions and not just being fantastic in programming, but without helping you in delivering something that the business need. And this was about people, and also one of the last thing that I want to mention is also the vision, because as a data science and intelligence team, we are a building block of the data supply chain that Francesco mentioned before, and this help and let us to be a data-driven company. And with the top management, with this strategic view, it's a very big opportunity for a data scientist to work in an environment like that. So this is my experience as a data scientist in WINDTRE. So if you have any questions, I'm here. I see the chat.
Francesco said goodbye.
Okay. I don't know if there are any questions for me.
They can email you.
Yeah.
Yes, of course. You can email my WINDTRE or find me in LinkedIn or my surname.
Allow me, I can put your email on the chat so they on the team chat so they can send you mails.
Okay.
Thank you.
Okay, great.
Also to Amida and Francesco. And Francesco.
Now, if there are other questions, if there are no questions, I would like to ask you, if there is anyone who can answer about the possibility of internship and stage at WINDTRE, if there is any program for internship and stage at your company.
Yes, of course. I don't know if there are the person from HR listening. Maybe they can answer better than me.
Yeah.
There should be someone, maybe Chiara. Chiara, are you here?
I'm not sure.
Yes, I see Chiara.
Yeah, she's here, but I don't know whether she's physically present or not.
If you want, as a participant of
We lost you, Amida. We cannot hear you. There is a connection problem with you. So.
Okay.
Much better.
Okay, maybe Chiara
Much
is
better.
coming. She has some technical issue.
Yeah.
Yeah, Chiara, when you hear me, is okay. So Chiara is here, and so she can answer better about our internship programs. So they were asking, I don't know if you heard the question, they were asking about the possibility of internship programs within our data unit. We don't hear you.
You're muted, Chiara.
She's not on mute. Maybe she's not connected with the right device. Yeah. In the meantime, I can say that I know that there are internship programs, and as I told you, we are very happy with these internship programs. And Amida is an example, and also recently other interns now joined the team, and I'm very happy about that, because really it's very good to be always updated, and students need the expertise that other members of the team have, but of course their fresh mind and passion create a lot of value. But the process, I don't know the process very well, so maybe Chiara is now managed to explain. Otherwise, we will text you with the details if Chiara doesn't manage to answer, because I don't know exactly how it works.
No, Chiara seems to work. Okay, we cannot hear you. No. You are
No, Chiara.
unmuted, but we cannot hear you.
Okay, maybe let's try with another question. If Chiara managed to set her microphone, I think that somewhere with the options, there are audio settings. If you on the left bottom corner, there are the mute microphone and then an arrow, and with the audio settings, maybe.
But she is unmuted. She was unmuted a few seconds ago. There must be an issue with the microphone.
Yes, I think maybe that there are
Bluetooth, maybe?
things like that.
In any case, while she solves the issue, maybe you can tell us how you entered WINDTRE.
Yes, I was contacted from the HR when I was in my previous company. So, as I told you, Marcello showed me the use cases that there were at that time. That they were very few, because when I joined WINDTRE, we were only three data scientists and maybe one data engineer. I think there was only Tagliaferri at the time. Now it has quite big team, and also the team of Francesco Fabri now is around 20 persons. And so was a new project, and for me it was very exciting, the idea to see this transformation from the beginning, and so I feel that what we have built in these 2 years, 2 years and a half now, yeah, it's part of me, because I remember when we joined, for example, the migration on the cloud was not even completed. Was at the beginning, so I remember was what means working with the legacy systems, and so now we have built a data pipeline that allow us to develop machine learning models very quickly, with a lot of use cases, and so it's a very stimulating environment, and so was very happy with the choice, because before in consultancy, really the problem was that very few time I had the opportunity to develop models, with a lot of time spent on data preparation, analysis, but without but then I was not able to see a project from the beginning to an end. So maybe you spend a lot of time doing a part of the pipeline and without seeing how it works at the end. So and was not stimulating for me. And now it's very stimulating, because I remember when I was in consultancy, I always say, okay, but I don't do models. I don't do so much models. Just maybe, yeah. Of course, I did some projects with models, but was not on a daily base. And now every day we talk about models.
Well, is there, okay. Wait, can you hear me?
Yes, yes, Prof. Perfectly.
If there are no other questions, I would like to thank personally the speaker, and I leave to Flora the stage for the
Thank you.
final comments.
Always
If I can make a proposal, Chiara, since you could not connect, would you be so kind to write in the Teams channel what are the procedures for the stage and the internship, so that the students will know whether they must send the CVs or, you know, or they must wait for a specific call or so on. So thank you very much, Chiara. Flora, the stage is yours.
Thank you. Thank you. Thank you also to Dr. Nigro. If it's possible, would be wonderful to have the slide. And I am really, really impressed from this lecturer. Thank you. Really, really thank you to all of you. And